We used cofactors to compute determinants of large matrices. Recall that a cofactor is a sign, positive or negative, times a determinant of a submatrix of the matrix we started with. We can also use cofactors to find a formula for the inverse of a matrix in terms of the entries of the original matrix. So in particular, if A is our original matrix, then the ij entry of A inverse is the ji cofactor divided by the determinant of the matrix. The confusing thing here is that the ij entry doesn't have the ij cofactor in it, but the ji cofactor. So our strategy to invert the matrix this way is first to compute the determinant. That'll give us our denominator. Then compute all of the possible cofactors by crossing out all the rows and columns one at a time. One row, one column in all possible combinations. And then we'll record those cofactors in a matrix and finally transpose the matrix, which will essentially turn Cij, the ij cofactor, into Cji, the ji cofactor. And then we'll put 1 over determinant of A in front of this matrix. Now, in my opinion, this method of computing the inverse of a matrix is a little risky because it involves lots of computations that you can do wrong. I think it's better to use row reduction. But let's try this anyway, just to understand how it works. Let's invert the 3 by 3 matrix 1, negative 6, 2, 0, 2, 1, 1, negative 4, 5. So first we'll compute the determinant. So that's 10, we're using the diagonal line method, 10 minus 6 plus 0, so 10 minus 6 so far from the positive lines, minus 4 minus negative 4, zero. Alright, so minus 0, 10 minus 6 minus 0 is just 10 minus 6, which is 4. Alright, now for every ij entry of this matrix, we're going to cross out its row and its column and compute the determinant of what's left and multiply it by negative 1 to the I plus j. Basically, remembering plus, minus, etc. So this cofactor matrix is, first of all, look at the 1, 1 entry, cross out the first row and the first column. The determinant of what's left is 10 minus negative 4, or 10 plus 4, so that's 14. And then we look at the negative 6, cross out that row and column, and we've got 0 minus 1 left. Now this entry gets a plus, and this entry gets a minus. Then this next entry gets a plus. We'll cross out the row and column containing this 2, and we've got 0 minus 2. Then we come down here to the 2, 1 position, cross out this column and this row, and we've got negative 30 plus 8. So negative 30 plus 8 is minus 22. And then we'll cross out the second row and column, and we got 5 minus 2 is 3. And then cross out the third row in the second, the third column in the second row. We've got negative 4 plus 6, which is 2. Then we cross out the first column and third row and get negative 6 minus 4, which is minus 10. And then cross out this row and column. We've got 1. Then cross out this row and column. We've got 2 minus 0, 2. So we have to remember this plus and then alternating signs from there down. I think I've got that, and I hope I have the signs right for the cofactors for the determinants we just computed. So let's simplify this. We've got 14, 1, negative 2, positive 22, 3, negative 2, negative 10, negative 1, and 2. So let me just compare with my notes. Okay, that agrees with my notes. So we've got the determinant, so we're going to have 1/4 times this matrix, but transposed, because we want the ij entry to have the ji cofactor rather than the ij cofactor. So inverse is 1/4 times this matrix transposed. 14, 22, negative 10, 1, 3, negative 1, negative 2, negative 2, 2. Alright, now let's check this. So if we multiply the original matrix by this, we should get the identity. Or if we ignore the 1/4 and multiply the original matrix by this, we should get 4 times the identity. So let's put the original matrix down here. 1, negative 6, 2, 0, 2, 1, 1, negative 4, 5. And let's just multiply these two integer matrices and see if we get 4 times the identity. So we have 14 minus 6 minus 4 is 14 minus 10, which is 4. Then 22 minus 18 minus 4. 22 minus 18 minus 4 is 0. Negative 10 plus 6 plus 4 is 0. 0. 2 minus 2 is 0. 6 minus 2 is 4. Negative 2 plus 2 is 0. 14 minus 4 minus 10 is 0. 22 minus 12 minus 10 is 0. And negative 10 plus 4 plus 10 is 4. Now to do that, I ignored the 1/4, and so I got something 4 times as big as I should have, 4 times as big as the identity. I could have put fourths everywhere and then multiplied to check to make sure that I get the identity. But I thought it would be easier if we left out the fraction and just remembered that what we're getting is 4 times as big as what we should be getting. The end.